Welcome back to this course, Intermediate Level Java. This course is a presentation of Coding Boot Camps. Here's the outline of our current session. So we'll look at exceptions, types of exceptions, handling exceptions. We'll take a look at a class hierarchy, because an exception is actually a class, how to extend our exception classes, and when to throw or assert exceptions. So let's start our session 3 discussion, exception handling. An exception is an error or a problem that arises during the normal execution of an application. So when an exception occurs, the normal flow of the program is disrupted, and the application may terminate abnormally, or it may return an unfriendly message to a user. Therefore, exceptions need to be handled in a way that the user can manage it and work through the exception. Exceptions can happen for many different reasons, and the following are some scenarios where an exception certainly will occur, but it's not limited, obviously, to just these 3 examples. So invalid data, so possibly a user enters numeric data when date data is expected, or alpha characters instead of numeric characters. A file that needs to be open, or some kind of resource that needs to be open, cannot be found, so memory or a device, a file, those are all examples of resources that cannot be found. Or a network communication is lost during an initiation of a network communication. So we have a multi-tiered application, and suddenly the network connection is lost. That'll certainly return an error and an exception. Or our Java virtual machine has run out of memory. That can also be a very frustrating type of exception. There are generally 3 types of exceptions that we will be discussing, and that you'll have to know how to handle in Java. Checked exceptions, sometimes called design time or compile time exceptions, are an example is a syntax error. The good news is that the compiler helps the programmer eliminate these exceptions. Unchecked exceptions, or runtime exceptions, can include runtime bugs, bad business logic, improper use, say, of connecting to an API, things that the compiler just cannot always check for. We talked about in a previous example needing a resource, and the resource is assumed to be there. Maybe it is there during some kind of testing, and then suddenly becomes unavailable. This would be an example of a unchecked exception or a runtime exception. And then there are general errors. So these can be exceptions that arise that are not foreseen by the programmer and that are out of control of the user, and are typically ignored in the code, and can rarely do anything about the error because it's just something that was not foreseen. An example could be a stack overflow. It could be a hardware problem, a memory problem. And these types of errors will generally not be picked up and by the compiler. So your code can compile fine, but because their errors can still occur during execution of code that compiles with no issues. Here's a good example of a small class here that's looking for an external resource. In this case, it's a file, and this can be written with no syntax errors and can compile fine, but it's dependent on an external file. So as you can see here, this file reader class is instantiated in in this class, this file not found demo, and you can see here the file is expected to be on the E drive file.txt, and again, syntactically this is fine. However, when it's run, if the file's not available, you get this very unfriendly error. So if the file is, that's something that can be foreseen, that the file may not be available. So what the programmer can do is handle the exception and let the user know that the file is not found in a friendly way. This is a message that the file is not found, but it's not a very friendly error for the user. And the message can also be formatted in a way that it will give the user some kind of instructions, so he or she can take action. One other thing about this checked exception here is the compiler will go through and enforce all of the syntax here. There is absolutely a way to use these class libraries, so if this is not syntactually correct, the compiler will return an error. So it won't be until this compiles that the user will be able to run this. But there still is an external dependency, so that obviously needs to be there for this class or this application to execute properly. Here's an example of an unchecked exception. So in this example here, this is an array out of bounds type of error. So we can see here we're declaring an array and it has 4 places, and we're actually trying to access the 5th place of this array, and that obviously will throw more of a runtime error in this case. This is going to compile without a problem. The compiler will not go down to the level of enforcing the indexes of the array, but when this is run, the output here is that the array is out of bounds, meaning that it's accessing trying to access a section of memory that's not there for the array. In Java, everything's a class, and all exceptions are subtypes of the Java Lang exception class. The exception class is a subclass of the throwable class. Other than the exception class, there is another subclass called error, which is also derived from the throwable class. Errors are those conditions that happen in the event of unexpected severe failures that are quite often environmentally related. They cannot be handled by the Java programs. Errors are generated to indicate errors with the runtime environment, such as JVM is out of memory, and again, recovery from these types of errors is very unlikely. The chances are that a support person or the programmer will have to come and troubleshoot and take action on resolving this type of error. And the exception class has 2 main subclasses. So IO exception inherits from exception, and runtime exception also inherits from the exception class. You can see here the hierarchy of the class exceptions. So from the Java Lang, from the object class, we have our throwable class, which has throwable. We has 2 classes from that inherit throwable. We have errors and exceptions, and just like we talked about on the previous slide, exceptions have runtime exceptions and other exceptions. So we can see the inheritance here for all of these types of exceptions and errors. And Java allows us to create our own exceptions, almost a custom exception, which will allow us to anticipate errors and handle them in a way that users can recover, the application can recover, the user will get a friendly message and can proceed to take some kind of action. You can return a message or a set of steps or maybe some kind of support contact information. So let's take a look at an example of a custom Java exception. So in this example here, we have our custom exception called invalid age exception, and it's inheriting from exception. So that's the extends keyword, means it's inheriting from the Java class exception. And we have our class where we're going to test the custom exception. And we can see here's a method called validate that actually throws the invalid age exception. So there's a anticipation that there could be an error, and we are handling that error or some kind of an exception. We're handling that exception. And we see here we have our main method where we're actually instantiating validate, and we're going to go ahead and run it. And if there are any kind of issues, we are going to be able to handle those exception issues. As we build the main method here, because there is, we're anticipating that we may introduce an error exception, we're going to use the try catch block, meaning we'll try to run a line. We'll try to run some of the lines in the try block. If any of them have an exception, they will move to the catch block, and the catch block will then manage what needs to be done or manage what we tell it to do for the exception. And if we take a look at the rules here, we're instantiating validate. Validates right here. We enter the integer age. It looks like the age here is 13, which is less than 18. So then we'll throw this exception about invalid. That will then immediately return that not valid. And the system here will return some other instructions for the user. If we had passed in an age that was greater than 18, we'd get a message here that they were welcome to vote, and obviously we don't throw the new invalid age exception there. So in this example here, the catch block is going to be outputting some messages to the user, so the user can recover or take some other types of action with running this application. So this is important to understand about the throw or throws exceptions. So if a method does not handle a checked exception, the method must declare it using the throws keyword. The throws keyword appears at the end of the message signature up in the header. Quite often your integrated development environment will either warn you or give you a runtime error that you do need to throw the throws keyword for the application to compile. And then you can use the throw keyword when you want to throw an exception, either by a one that you just instantiated. We just saw in a previous example of that, or an exception that was just caught. So just to understand the difference, the throws keyword is used to manage or postpone the handling of a checked exception. So we saw again an example of that with the previous application that we look like, whereas the throw keyword is used to invoke an exception explicitly. So if it is an error that we know is a problem with business logic, we would use the throw keyword to invoke that exception explicitly. This might not be something that's necessarily picked up by Java itself. In Java, methods can actually throw more than one exception. So we see here this method throws the remote execution, And if we take a look down here, this method here, withdraw, throws the remote execution and the insufficient funds exception. Notice here with this method, the exceptions are in the header of the method, and they are in a comma separated list. So the two exceptions are separated by a comma. A finally block follows a try block. It follows a catch block. The finally block is a block that always executes. It does not matter what the occurrence of the exception is. The finally block allows you to run any kind of cleanup type of statements that you want to execute, no matter what happens in the execution of the application or what happens with respect to the error. The finally block appears at the end of the catch blocks and has the following syntax. If you use try catches, chances are the finally block is optional. There could be exceptions to that. So quite often your compiler or your IDE will alert you either with a warning or with an error if the finally block is required. For an exercise, let's try this. Predict the output of the following Java program. So let's take a look at it, and we can see here some options, some possibilities. Try to predict it, but also key it in and run it and see if what you predicted, what your intuition told you is going to be true. And if your intuition was wrong, think about why it was wrong. So to summarize, we talked about exception types, handling exceptions, why we need to handle exceptions, the exception class hierarchy, extending the exception class, and when to throw or assert exceptions.